Hi viewers, welcome once again to my channel Israeli Math Concept. In this tutorial, I will teach you basically the topic derived trigonometric ratios. Remember that this topic is very pertinent, most especially for students that are still in secondary school and as well for students that are still in their higher level of learning. If this is your first time of viewing, please consider subscribing to my YouTube channel and as well hit the notification bell so that whenever I drop a new math content, you would be notified. Let's say for instance that we are given the sine of an angle theta to be A over B, and we are told that our theta is an acute angle. Remember that an acute angle are those angles that are less than 90 degrees. So if an angle is up to 90 degrees, we say it's a right angle. But when it is less than 90 degrees, we can categorically say that it is an acute angle. So we are given the sine of an acute angle theta to be A over B. Then we are asked to find the cosine of this same angle theta and as well to find the tangent of this same angle theta. So how do we basically find the cosine of this angle theta and the tangent of an angle theta? Having known that our sine theta is equal to A over B. That is basically what this topic is all about. So as we proceed, I guess you will understand better. So to find the cosine of this angle theta and the tangent of this angle theta, having noted that we are giving the sine theta to be A over B, how do we find it? It is very simple to do. First thing first, we shall draw our right angle triangle. So this is the right angle triangle. Remember that a right angle triangle is a type of triangle that one of its angle is 90 degree. And obviously the angle here is 90 degree. So we shall first of all represent this ratio of sine in this given right angle triangle. Let's first of all label this right angle triangle to be A, B, and C. So we shall put the angle theta in this place. And obviously, the angle theta is an acute angle because the angle we have here is less than 90 degree. So remember that the sine of any given angle, the ratio of it is given as opposite over hypotenuse. Then the cosine of any given angle is given as the ratio of adjacent over hypotenuse. And also remember that the tangent of any given angle is equal to the ratio of opposite over adjacent. So we can recall this formula using our trick, which is SOHCAHTOA, where the S stands for the sine and the sine is opposite over hypotenuse. The C stands for the cosine and the cosine is adjacent over hypotenuse. And finally, the T stands for the tangent, and the tangent is opposite over adjacent. So coming back to this right angle triangle, remember that whenever the angle we are given is facing directly, we call that very place opposite. So automatically the opposite is the A, so we put A here, and the hypotenuse, which is the other part of the ratio for sine, is our B. And remember, hypotenuse is the slanty side or the longest side of a given right angle triangle. So this is the hypotenuse, which is the side AC. So we have it to be B. So here we have our B. So obviously, before we can be able to find the cosine of this angle theta and the tangent of this angle theta, we shall first of all find the remaining side, which is side AB. To find our side AB, we shall use Pythagoras theorem. And remember that Pythagoras theorem states that the square of the hypotenuse side, remember the hypotenuse side here is our side AC, so the square of the hypotenuse side of a given right angle triangle is equal to the sum of the square of the other two sides. The sum of the square of the other two sides. And remember, the other two sides are the side BC. So we have side BC and side AB. So also we have side AB. So this is basically Pythagoras theorem. So we shall impute the values we have in this triangle in this given Pythagoras theorem we just stated. So our side AC, this is our side AC, we have it to be B. So we have B squared, and that is equal to our side BC. This is our side BC. We already have it to be A. So we have A squared, then plus our side AB. This is our side AB, which is basically the side we want to find. And we don't know exactly the value, so we can still leave it to be side AB squared. So making our side AB squared the subject of this given equation, we then have that our side AB squared is equal to, we have B squared, then A squared crossing over will be negative A squared. So let's take the square root of both sides so as to remove the square we have here. So taking the square root of both sides, we have the square root of the side AB squared, which is equal to, we also have the square root of B squared minus A squared. And remember, mathematically, it is the square that cancels out the square root, and then we are left with our side AB, and our side AB is equal to the square root of B squared minus A squared. Remember, based on laws of indices, we can still put this as B squared minus A squared all raised to the power of half. Remember that laws of indices, it states that whenever we have something like a base number raised to the power of half, it is the same thing as taking the square root of that base value. So this is example what I replicated here. Alright, having gotten the side AB to be B squared minus A raised to the power of 2, then all raised to the power of half, which is the same thing as taking the square root. We can then find the cosine of this angle theta and the tangent of this angle theta. Let's start with the cosine of this angle theta, which is an acute angle. So we then have that the cosine of angle theta, remember that cosine of any angle theta is adjacent over the hypotenuse. So automatically the adjacent, let's come back to this given right angle triangle. The adjacent is the side AB. And the side AB, we have to put it here, AB, all over. What is our hypotenuse? Our hypotenuse is the longest side of this triangle, which is our side AC. So we also put side AC. Okay, but obviously we have that this is something as cosine theta equal to our AB. This is our AB, which we found to be B squared minus A squared, all raised to the power of half. So here we have B squared minus A squared, all raised to the power of half. Then all over our AC. Remember that our side AC is our B. So that is all over B. So let's also take for the tangent of theta, and the tangent theta is equal to, remember that the tangent of an angle is given as the ratio of the opposite side of the given triangle all over the adjacent side. So automatically the tangent of this angle theta is equal to the opposite, and the opposite is where the angle theta is facing directly, which is side BC. So we have side BC all over the adjacent. Remember the adjacent is side AB. So we have side A, B. And remember that this is the same thing as saying that tangent of our theta, our acute angle theta, is equal to what is our BC? Our side BC is our A. So here we have our A all over. What is our side AB? Our side AB, we found it to be B squared minus A squared all raised to the power of half. So we succeeded in finding the cosine of our acute angle theta, and this is the result we have for it. And also we succeeded in finding the tangent of our angle theta, and this is also the result we have for it. So what are you learning from this topic? It is very simple. Whenever we are given the trigonometric ratio of any identity, either sine or cosine or tangent, then we are asked to derive the trigonometric ratios of other identities. What do we do? First thing first, draw your right angle triangle, impute the values that we are given, and once you've imputed the values, you can then find the remaining part of the triangle. And after you found it, you can then go ahead to find for your cosine theta and for your tan theta respectively, depending on the question you are given. Actually, it mustn't be only cosine theta and tangent theta. We can still be given something like secant theta. Secant theta. Remember that secant is simply the reciprocal of cosine. We can also be given a question like to find cotangent, cotangent, cotangent of an angle theta and secant of an angle theta. And remember that the cotangent of an angle theta simply means the reciprocal of your tangent. So whichever question you are given, first thing first, trace and put the initial value of the ratio you are given, and after which you can go ahead to find the respective ratios of other identities you are asked to find. This is basically how to solve a given problem of this kind. Catch me up in my subsequent videos. I shall teach you also how to solve practical problems as relating to derived trigonometric ratios. Remember to hit the notification bell so that when I drop a new maths content, you will be notified. Remember to reshare this video. Goodbye.